You can transfer.
Every one of your answers should look basically like this. This is problem number one. I want y'all's attention. Evan, I'm not going to ask you one more time to move, okay?
Is that 81?
Move your desk over there. Move your desk over there. No, go ahead and take your whole desk.
Come on, then move. Come on.
Every one of your answers should look basically. Did you just curse?
No, I didn't.
Every one of your answers should look basically like this. Difference of two squares, factors like this. Square root of each one, 64 and 81, right? We've got 8x plus 9y, in this case, and 8x minus 9y. If you've got any other type of a format to your answer than this, that's not right. You know, it has to look like this. Two sets of parentheses, two binomials, a plus and a minus. Okay? This is how you factor the difference of two squares. There's no other way to do this. Some of y'all, I just saw one simple. Number 10. 1 minus 144. The 4. Okay. Okay. What this is going to happen now? 1 is a perfect square, isn't it? Because it's 1 times 1. Two sets of parentheses. What are my signs in the middle? Plus and minus. Okay. Now, square root of 1 is 1. What's the square root of 144? 12. 12. What's the square root of t to the 4th? D. D squared, yeah. Now, you don't go any further than this. Because this, you know, you might be tempted to think, well, I see a minus sign, I see something squared. I know 1 is squared, right? It's a perfect square, but 12 is not. So t squared is a perfect square, but 12t squared is not. Right? It's not a perfect square. So you have to stop here. So don't go any further than that. Those are your two answers. Okay, one more. Number 12. Okay. Okay. Now, to define this as the difference of two squares. Actually, you're not going to be able to do that. You just have to factor and check. Yeah, some of these were not different of two squares, were they? Okay, this was different types of factoring situations. This is what we're going to have to do here is redefine this as the difference of two cubes. Yeah. You have to rewrite 8x to the 6 as 2x squared cubed. Okay? Why? Because 2x squared times 2x squared times 2x squared, right? What does that equal to? 8x to the 6th power, right? Add your exponents, multiply the numeric part. So you get 2 times 2 times 2. Can y'all see well enough? Change mine away there. Okay, so defining that as 2x squared raised to the 3rd power, I don't have to do anything to y to the 3rd. It's already a cube. Now we're set up to use our rule for the difference of cubes. All right? So, let me go ahead and move my answer down here. So, first set of parentheses, 2x squared minus y. You see that? I've got to take the cube root of each one of those. Just knock the 3 off, and what you've got is what goes in your first set of parentheses. Now I've got, remember, 3 terms here. Difference of two cubes. Are my signs going to be alternating, or are they all going to be pluses? All all pluses. So what's my first one going to be? The way we initially thought about how to arrive at the three terms is to take this first one and square it. So what is 2x squared squared? Yeah, be careful there. Be careful, the mistake I could make as well. Now, what's my middle term going to be? You know, this is y squared. Yeah. What's my last term going to be? And that's it. Okay? All right.
Can you do, wait, are we still on?
Yeah, let's do one more on this page and we'll move on. Tanisha, give me one too.
No, 15. That was just
Cool. So one you're thinking of this. Okay, 15.
I mean, I can do it now that
You can go.
Yeah.
coming back to visit.
Okay. So what I'm going to do, I'm going to have to redefine x to the 16th as something, x is something squared. So what should that be? What times 2 is 16? 8. So let's redefine this as x to the 8 squared. Why to the, you're close. Y to the 4 squared. Okay. Now, the difference of 2 squares. What's the sign? Help me out here. What sign is going to put my parentheses here? Okay. Daniel?
Yeah.
What are my terms that go in between or in the parentheses here? Just knock the 2's off and plug them in. Knock the 2's off and stick them in.
Oh, 8 to 8. And, why?
Okay. Okay. Now, I'm gonna have to extend the page here. Now, I'm not done yet, am I?
No.
Because this can be redefined as the difference of 2 squares again, but can I do anything more with this? No, you can't. That's right. No, you can't. So, what I've got to do, I'm going to carry that. In other words, since I can't factor this one anymore, we call this one prime. X to the 8.
The plus one?
Yeah, the plus one is prime.
So I'm going to bring it down.
But, so now let's redefine x to the 8 as what squared? X4. Let's just go ahead and write this out. We know we got a plus and a minus. We know that we're going to put x4 here and x4 there, right? What about y to the 4th? What is square root? Okay. Now, I've still got one more step to go through, I believe, because this factor, again, is what we call prime. That one is not. It's also the difference of 2 squares, right? So, my last step in the process, bring down the prime factor first. Now, what are my signs going to be here? Plus, minus. Daniel Reese. What terms do I stick in here? What's the square root of x is 4? Okay. X squared. What's the square root of y squared? Now, this is now prime, isn't it? Is this prime? I know it's got a minus on it, but this time it is prime, and the reason it is, it ain't the difference of 2 squares no more. One's a square, one's not. It's just a difference. Okay? Just because you see a minus sign don't make the difference of 2 squares. It's at least just a difference. And that's all this one is. So, number 9. Let's make this the last one, and then let's move over to 56. No. Okay. I'm just going to set it up, Anthony, okay? You're gonna finish it, just for time's sake here, I'll set it up for you.
Just take 56.
Yeah, it's on 54 actually, I'm gonna set one more up. This is 128 minus y to the 7th z to the 7th. Now this is gonna be the difference of two higher odd powers. And the y to the 7th, z to the 7th is telling me in all likelihood that this first term here, 128, can be redefined as something to the 7th power. You'll get used to identifying these.
How?
Practice.
Well, it'll be great.
And if you're not sure, then you start trial and error is the way you do. You start figuring, my first bet with a number that's like 128 is to first start with what is 2 times 2 times 2. Take your calculator out and just start hitting it. 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. And let's ask ourselves, is that equal to 128? 2 times 2 is 4, 8, 16, 32, 64, 128. So that means I'm going to redefine 128 as 2 to the 7th power. Okay, so what I'm going to do, I'm going to redefine this as 2 to the 7th minus yz in parentheses to the 7th power. Now, this is follows similarly the rules of the difference of two cubes, but it's the 7th power, higher odd power, not a 3. So I'm going to take the 7th root in this case of the 2 to the 7th and the yz to the 7th, which means I'm going to have a binomial 2 minus yz. You take the 7th root. If those were both numbers raised to the 9th power, you would be taking the 9th root. What that 7 does is it tells you how many terms that you have in the bigger factor here. The reason your strong difference of two cubes has 3 terms in the second factor is because each numbers are raised to the 3rd power.
Why would you?
Because it's 2 to the 7th to 129.
Really?
Okay, so now what you got is 1, 2, 3, 4, 5, 6, 7. And remember, first of all, we have difference of two higher odd powers, like the difference of cubes. Every one of the signs here are going to be plus, okay? All the way down. Now, each one of these terms in this factor are going to consist of a 2 raised to some power and a yz raised to some power. And the 2, the first term of the second factor, the 2 is going to be raised to 2, so what I'm going to determine the power on is going to be 1 degree less than what I see in the original problem. So I'll start out with 2 to the 7th. My first term is going to be 2 to the 6th. And then yz, the second part here, I hope y'all can read this, is going to be raised to the 0 power, okay? So let me rewrite this, because I don't have enough room here. I'm not going to do the whole problem, so let me make this big enough so you can see. I've got 2 to the 6th, and then I've got yz to the 0 power. That's my first term, okay? Yeah, and what's going to happen with my 2, there's going to be a factor of 2 in each one of these places. And what I'm going to do is I'm going to descend from 6 all the way down to 0 throughout these 7 places. So I got 2 to the 6th, 2 to the 5th, 4, 3, 2, 1, 2 to the 0 power. Remember, anything to the 0 power is equal to the number 1, right? So y to the z to the 0 power, each of the succeeding terms, I'm going to have yz raised to the 1st, 2nd, 3rd, 4th, all the way to the 6th. It ascends up. 2 descends down to 0. So we start at 0 with yz, work our way up to 6. We start at 6 with the 2 and work our way down to 0. So my last term here, plus, is going to be 2 to the 0 power, and yz to the 6th. Which, these both simplify. If I come back down here, and I need to simplify this, don't just stop with writing those in. You need to say, what is 2 to the 6th? What is 2 to the 6th? Well, yeah, if 2 to the 7th is 128, well, divide it by 2, and that gives you 2 to the 6th, 64. And since yz to the 0 is just 1, don't write it again. 64 plus, and you got, your spaces on down, 2 to the 0 power is 1, then y is equal to 6. You can just leave it like that if you want to. Or write it as y6, z6.
Oh, defense.
Yeah. You see how that works? So you fill in the rest of that. All right?